This is a video for AQA Further Pure Mathematics. This is Vectors section 2.4, where we're looking at the intersection of lines in 2 dimensions. Well, there are 3 different things that can happen if we've got lines drawn on a plane. You might like to think about those before you look at the answers coming up. But the first one is maybe the obvious one to most people, which is that they can intersect at a single point. But there are 2 alternatives, and those are that the lines are parallel and non-intersecting, and thirdly, they could be parallel and intersect, or what we call collinear. Now, you'll have met at GCSE the idea of using simultaneous equations and the equations of graphs, the Cartesian equations of graphs, to solve for the points of intersection, or even to determine whether lines are parallel or not. We're going to look today at how we can use vector equations to do a similar thing, to find points of intersection. Well, here we have 2 lines in their vector form, so R1 and R2. You can see, just for clarity, I've got the X components and the Y components in different colours. So we could rewrite those to start off with in column vector form. So this one would mean that R1 was equal to 5 plus 2t and 11 plus 6t. And the second one implies that R2 is 2 minus s and 4 minus 5s. Notice that we've got 2 different parameters there, s and t. This means that we're not going to get confused, so you must make sure that when you've got different lines that you use different letters for the parameters. So from those 2 sets we can say, well, when the lines intersect, then R1 must be equal to R2, and in which case both the X and the Y components must be equal. So we can equate the X components to give us the fact that 5 plus 2t must be equal to 2 minus s, and the Y components say that 11 plus 6t must be the same as 4 minus 5s. So there we have a pair of simultaneous equations that we can solve to find s and t. Well, here's our 2 equations written out again, and so let's call the first one equation A and the second one equation B. Then usual methods for solving simultaneous equations. We can take equation A and multiply it by 3, which gives us 15 plus 6t is equal to 6 minus 3s. And then that gives us a third equation now, C, and if we subtract b from c, so we do c minus b, then that gives us 4 on the left hand side is equal to 2, and then plus 2s on the right hand side, and therefore we get that s is equal to 1. Now that's actually sufficient, because we could substitute s into our equation R2 to find the point, and if we do that we get that s equal to 1 means that R2 is equal to 2 minus 1, so that's I, and then in the j direction we've got 4 and minus 5 times s, so that will be j is equal to negative 1, so we get I minus j for the vector. Or in other words, we have that the point, the intersection, is at the point 1, -1. Now what we could do is to look at the value of t as well and check that that value substituted into the equation for R1 gives us the same intersection. That's the end of this video looking at the intersection of lines in 2 dimensions. In the next video we'll be going on and looking at what happens when we have lines in 3 dimensions.